Okay, this problem is also a continuation of our Zoom meeting from earlier today. This homework question was also asked. This is from section 6.4 about vectors, and it's on page 397, number 79. And so it reads like this. A car weighing 2,500 pounds is parked on a hill inclined 15 degrees to the horizontal. Neglecting friction, what magnitude of force parallel to the hill will keep the car from rolling down the hill? What is the force magnitude perpendicular to the hill? So this is basically what they're asking. They said what force parallel to the hill, to the incline, would keep it from rolling down the hill. So basically they want to know what is this force in, if I call that the x direction. And then they want to know perpendicular to the hill, this is this red line, what is this force? So the perpendicular force that we need to figure out is F sub y. That's what we need to figure out. This black line that you see here is the force of gravity that's going down. That is the resultant in this case, or the addition of this little x component and this y component right there. The angle that it makes in between is 15 degrees. And so what we're looking for is this length or magnitude across from that angle. Now, this forms a right angle, which is very nice. It's right here. F sub x and F sub y form a right angle right here. So that means that we can use our trig functions right there because we have that right angle going for us. So if you say, if I have an acute angle here and I need to know this F sub x, what is the trig function that involves opposite? And this is the hypotenuse. Opposite and hypotenuse is sine. So we'd say that the sine of 15 degrees, the sine of 15 degrees is opposite F sub x over hypotenuse 2,500 pounds. And so we could solve for F sub x by multiplying both sides by 2,500. And that will give us the horizontal force that would, it would need to stop the car from rolling down the hill. And so that's going to be 2,500 times the sine of 15. And that gives us 647.0 or 647 pound force in that direction would stop it. What is the force perpendicular to the incline? What is F sub y? How could we find that? Well, if we know this angle, F sub y is adjacent. What trig function do we know that involves adjacent and hypotenuse? That would be cosine. So we could say that the cosine of 15 degrees is equal to adjacent, F sub y, over hypotenuse, 2,500. And we could solve for F sub y by multiplying both sides by 2,500. 2,500 times the cosine of 15 gives us 2,400 and about 15 if I round to the nearest pound. 2,415 pound is the force perpendicular right here, that red one. And so that is that one.